Okay, tak ada soalan. It's okay. I hope that you did your exercise and then hopefully you understand it. Okay, just to highlight, okay, in that exercise, I believe that the weight percent, okay, I should have additional. If I have blank slide, I'm gonna on some data that you need to take care before you can proceed with calculation, because I know that most of you, I comment it is you having a good the way that you solve it correctly, but when I notice again that there's a things that you need to correct first, and then the way that you calculate it is correct, but the value that you put it might be a little bit wrong. Okay, why I'm saying that? Okay, because if you notice that you have mesh here and you have weight percent. Okay, so first thing, when you have this kind of question, for example, in a crystallization, even it's not question, or in a real case that you having you giving a task to calculate the crystal growth rate and so on, and when you do the sieving experiment, you sieve it, you normally using sieve tray, and then you take it out, and then you make a measurement, and then when you calculate the weight percent, okay, normally it's going to be 100%. Okay, it's going to be 100%. But if you add on everything, okay, the percentage is not 100%. So what you need to do, you need to normalize it. Okay, let's say you add on everything. Let's say this is 4.4, 16.8, and so on. Okay, you tambah-tambah, you dapat kat sini 98%. Alright, so you have balance of another 2% to become 100%, right? So what you need to do, you need to normalize the weight percent. How to normalize? So all of this 4.4, you're going to divide with 9.98, all right? And then this 16.8, you divide by 98, and everything will divide by 98, and then you're going to get later on all the percentage here are going to be 100%. So with that 100%, this new normalized, this one that you're going to use it in your, you need to calculate the n, right? Delta L over delta n, for example. So you have like times the density times the weight percent. So use the new normalized weight percent. I think that is the only mistake that I haven't comment. Most of you that pass me your solution, but I just noticed that the weight percent is not 100%. So you need to normalize it, and then finally you input that weight percent here to calculate your n, the number of crystal. Okay, so that is basically the one of the note. Okay, you need to take care. All right, and after that, okay, remember that you're gonna have like 1 minus WF. Okay, so that is another table. So what you're going to do, you're going to compare this one with the normalized one. Okay, not this one. The experiment that not reaching 100%. So must compare with the normalized weight percent. And then you're going to get like error kalau you nak calculate error. Okay, so that's all on the crystallization on the growth rate. I hope that everyone will take note on this, okay, because it's just a small data, very small data, whereby it's not reaching 100%, but they contribute to the mistake. When you do calculation, you're gonna do a mistake here, okay, wrong weight percent value. So finally, of course, you're gonna get this L versus ln n, you get your intercept, but your intercept, for example, the correct answer may be 16, maybe you get 18, little bit up, the value may be a little bit way, a few percentage from the actual, the correct answer, okay, but here, you're gonna miss some marks, for sure, because later on they're going to impact your ln n. Okay, ln n here, because normally if you calculate the first one, maybe you get 8, maybe you get like 9 point something, little bit higher value or little bit lower value. All right. Okay, then, okay, today we're gonna do on the drawing. So this drawing chapter, I'm gonna implement the new approach of teaching, whereby we're gonna start with exercise. Okay, when I look back the column, actually I forgot to put that the drawing exercise in that column, but it's okay. We can do it now during class hour. All right, we're gonna do it together. All right, you have to do it. Of course, I will facilitate. Okay, and the fastest way is to use your Excel. Okay, I advise you for this exercise, you use Excel, because if you use graph papers, it will take, I think, not even 2 hours class, maybe until tomorrow you will finish plotting your graph. Okay, so first thing we're gonna do the exercise is plotting the graph in drawing. Okay, so today is gonna be like little bit free and easy, because you're gonna do exercise and then show me. Share your screen and then show me how the graph gonna look like. So they're gonna have like 2 type of graph. From that graph, okay, what is the purpose of that exercise? Okay, so the purpose of the exercise is basically to expose, to get to know, okay, the theoretical part of drawing. Okay, the theoretical part of drawing. What is the rate of drawing? Okay, you have to know what we call it here, rate of drawing. Okay, and then what is the phases that you have in that rate of drawing, because you're gonna observe from rate of drawing the graph. So what are the phases involved in the drawing? So from there, you will know the phenomenon of drawing. All right, what happened actually in drawing? Once you obtain the drawing curve. The drawing curve is basically the graph that you're going to plot later on. Okay, and then after you have that graph, and then you understand what is the phase involved, what is the phenomenon involved, and later on, then you know that what are the equation that you can establish from that experiment, and then you can use it to calculate what. Okay, so I will not go to the following the material that you have, but rather than we're going to start with exercise. I hope that everyone will participate. You're going to use your Excel, because if you use Excel, you're gonna be very fast, right? You're gonna be very fast. So then we're gonna take maybe the most is maybe to plot one graph less than 15 minutes or 20 minutes once you have the data, right? Oh, I supposed to push the data, and it's easy for you to copy and then paste it in your Excel. So it's gonna be like 5 minutes. You already have the graph. All right, I will do it after this. So, okay, so we're gonna skip a little bit about this equipment and the rest. So we're gonna going back later on. Once we complete this one exercise, and then from that exercise, there are certain things that need explanation. So that one will be referred again to the slide, the beginning slide. So don't worry about this. So we're gonna know about this equipment. Of course, the equipment I will leave it to you for you to do your own study. Okay, the equipment of drawing. So this is the equipment of drawing. It's not limited to the to this 1, 2, 3, 4, 5, 6, 7, but rather than you can have more than that. So this is just some of them. Okay, so this is like self-reading. Okay, you need to find on your own if you need to know additional from the one that you already have in the slide. Okay, and if you don't understand how it functions, so next week we can discuss about this on this equipment of drawing. All right, so additional info you can Google. You can easily find a lot of photos, a lot of tray dryer type, for example, the dryer type, right? And then like these parameters, for example, vapor pressure, and then you have humidity and dew point and so on. So this one also later on, once we come across with the equation that require you to find this parameter, then I will go back to this slide. So it's rather that then you expose to equation that going to use that, and then we're going to go back to explain what is that, rather than explaining the parameter first, and maybe a week after that we're going to come across with the utilization. So I will change that one. So rather than we meet first the equation, from equation we explain where you can get all the what is the meaning of that parameters and how to calculate it. All right. So this humidity chart also, when you want to use it, I'm gonna explain to you how to use this one correctly. Adiabatic saturation temperature also the same. All right. So wet bulb temperature also the same parameters. When we come across equation that going to utilize this, then we going to go back to this one. And then equilibrium moisture content also the same. Okay, so most of them are contained in equation. All right, so we're going to expose to equation, later on explanation of this, right? Because previously I explaining everything, but when we came across with the equation, nobody remember that. So it's better that I try to deliver it backwards, meaning that you expose to the equation, then later on we're going to explore, okay, what is that? Okay, this one. Okay, now we're going to move up to this part. Experimental determination rate of drying curve. Okay. So this is what we're going to do the exercise. We're going to establish the drying curve. We're going to plot the graph, because this is a very basic fundamental. Okay, before that, before we move on to the exercise, of course, we want to know what is a drawing actually. Okay, kalau you tak kenal drawing, so how you want to know why you need to plot this one? So what is happening actually? What actually you are removing or separating? Because we are in the separation process, right? We are separating something. Okay, in drawing, what happened is that, okay, drawing normally is you have solid. So in your solid, you have water ataupun moisture. So what happened? We want to remove this away from the solid. So when the solid without water or moisture, so what happened? You have dry solid. So this is drying. Okay, drying is you dry something. Contoh, you pakai hair dryer. Okay, you want to dry your hair. So what happened? You notice that, okay? Most of the application ada dalam you punya daily life of drawing. The drawing punya concept. But maybe you did not notice about it. Do not notice. Kalau hair dryer, for example, you have a wet hair and then you pakai hair dryer. Dryer tu kalau you notice that you have like a different setup, like for example the flow, panas ke atau biasa di heating maybe the same. Okay, the heating you cannot control, alright, because they have like dia punya coil yang heat up. Alright, so let's say this is like, I think it's like this tool. Okay, here. So what happen kat sini, normally dia ada apa ni, fan. Kat sini dia ada heater. Kalau you perasan, kalau you buka, so what happen, dia akan sedut. Blower ni akan suck the air. So dia akan in contact with heater ni. So yang keluar kat sini adalah hot air. Okay, hot air tu contact dengan you punya wet hair. Okay, wet hair, kalau you imagine ada apa? Ada solid, hair tu dalam bentuk solid. You ada wet, you punya moisture lah ataupun water. So they are removing, let's say this is your hair, and then you are removing H2O away using the hair dryer. Example, so this one, this is the concept of drying actually. You see that dia ada kat sini kalau you imagine you akan ada boleh adjust speed. Okay, fan speed. If you have more speed, you have more air velocity. Air yang coming more. Alright, you have more air, you be drying, rate of drying become faster. If you put it a slow speed, the rate of drying is become slower. Betul tak? Kalau yang pernah pakai lah. Alright. So, kat situ dah ada concept of drying by manipulating the air velocity. You see? So, what is the principle is very simple. They apply to the hair dryer. Okay? So, the purpose is to remove moisture or water lah. Okay? So, that is drying. Or in industrial application, most of the time we involve water lah, water removal or moisture. Normally moisture. Kita tak pakai water yang banyak. We cannot remove a lot of water using drying. We can do that, but it will take a very longer time. It consume a lot of time. For example, you ada satu baldi, you have one jug ataupun one vessel, satu bekas yang ada air yang banyak, but you want to use drying punya method. Boleh. Can, of course. But it gonna take maybe a few weeks to remove all the water using drying. So that's why the drying is not practical if you have a lot of amount of water. Okay, drying not practical if you have a lot amount of water. Okay, kalau water banyak sangat tak boleh. So apa yang sesuai? If you have a lot of amount of water, you can use evaporation. You ada another method lagi, mungkin evaporation, mungkin you boleh use mechanical drying. Okay, you can use, there's also other type of methods, alright, instead of drying. In industrial application juga, not necessarily involve water being removed, but solvent also can be removed for drying. Okay, normally it's a relatively small amount of water lah you want to remove, then you can use drying. Okay, that's why it's very important to know what is your process behavior, what is the stream that you have, and then what phase that you have. For example, you have solid and water. So how much the water that you have? Is a lot or just a small amount? If it's just small amount, then you can choose drying. If a big amount, don't want to choose drying because it's not practical. Yes, you can remove it, but it's not practical. Okay, so that's why we expose to you to a lot of methods that you can use to remove water, for example, to separate between liquid and liquid and so on. So finally, you the one gonna decide it, which one is practical at that particular time. And of course, in terms of business, is economic of scale is giving a benefit to the company. Okay, question, ada soalan tak? Okay, kat sini, drying, at the first punya slide, removal of relatively small amount of water or organic liquid. Normally solvent lah, kalau ada industrial application. Okay, dia boleh juga remove solvent, but normally most of them are removing water lah. Water is removed as a vapor by air. You have to understand. Water, this is solid, for example, wet solid. So water removed as water vapor. Okay, water jadi vapor. So daripada liquid, they become vapor. How they become vapor? Because you have like evaporation. Okay, you remove by evaporating the water, become vapor. Okay, so but if you have large amount of water, so you need to use evaporation. Okay, water is removed as vapor. Okay, the difference is that you remove juga dalam bentuk vapor dalam evaporation, but you at its boiling point. Maknanya you kena, kalau dalam bentuk yang banyak, so what happen? You apply heat. So heat sampai dia jadi boiling, and then barulah water tu remove as vapor. Sama juga vapor, tapi you kena boil up. So what happen? You need energy. Okay, you apply more energy to them. Okay, other than that, you boleh pakai mechanical. For example, presses, you press lah. Like macam you baca, you do laundry, you basuh baju. Okay, tak ada lah, katalah tak ada spinner. So you kena perah. So press, you remove that water. Objective you to remove water. Yes, you achieve that. Alright? Or you can use centrifuging. Centrifuging ni dia macam spinner. Spinner tu sebenarnya centrifuge. Alright? Dalam apa ni you punya washing machine tu ada spinner tu dia pakai centrifugal. So dia centrifuge so that water tu dekat certain velocity dia akan away from your clothes, wet clothes. Okay, tapi dia stay lagi wet lah. So that's why you buat apa? Next, you buat bila wet clothes tu you pergi kat you dry. Okay, you dry dekat luar rumah tu, you sidai lah dia. Okay, so dia ada wind coming in contact. Kalau cuaca panas, it's very sunny day, maybe you dry in the morning, afternoon you dah boleh collect, dah kering, dah dry. But if the weather is not so good, okay, so apa ni rainy season, for example, rainy day, so maybe it takes like another day, then it can get dry. Because of what? Because this airflow and temperature and surrounding impact the drying rate. Okay, give an impact to the drying rate. So we're going to look on that, how it impact the temperature, the velocity, and so on. Okay, so normally drying is a final processing step for packaging and makes many material more suitable for handling untuk packaging. So sebab apa? Bila you dah remove water or moisture, so what happen? The mass akan kurang. Okay, just imagine before you remove, you ada mass solid plus water. So when you remove water, you just left with the solid punya mass. So mass is reduced. When mass reduce, kalau yang biasa buat sending parcel, dia bergantung pada mass kan. Mass you banyak, you kena charge banyak. Mass you kurang, you kena charge kurang. So sama, it's the same thing. You reduce dia punya mass, you bayar kurang untuk transportation, for example. Okay, and another part, drying important untuk biological material. Because of what? Biological material ni, the moisture content must be as low as possible so that the microorganism will not active. Okay, kalau dia exceeding 5%, microorganism start to active and then they gonna be eating your material and your material will be the shelf life is gonna be shorter. Shelf life meaning that cepat basi, dah tak boleh pakai and so on. Okay, tu kena tengok lah. Alright, so this one I will not go on method of, well, I will explain a little bit of it. Method of drawing based on batch and continuous. I know that you know what is batch, what is continuous. Okay, operation is very simple. And it could be based on physical contact, for example, direct contact. And then you direct contact dengan heated air. Ataupun you apply vacuum. Okay, they have a vacuum drying. Whereby you do drying in a vacuum condition. So we call it vacuum drying. Right? Or you can also apply freeze drying. You buat drying dalam keadaan freezing. Example dalam keadaan freezing is just imagine water, sebab you ada solid, you ada water. So water tu when at the freezing temperature, let's say below than 0 degrees Celsius, you put in freezer. Freezer for example. In freezer, so you akan observe that it's become ice. Betul tak? Liquid tadi, water akan jadi ice. So what happen dalam freeze drying? Normally, kalau you buka top side, dalam freezer tu, top side is yang beku tu, you buka, you akan nampak vapor moving around, right? So dalam freeze drying, normally dia akan ada sucking system, dia akan tarik. They will remove the water vapor. So bila dia remove, water akan reduce lah. So that is dalam freeze drying. Okay, so equipment ni I will skip. So this is for you, your homework, your task to read through, because probably you're going to have another quiz for this particular topic. So they're going to touch on this, some equipment. Okay, here also you have like animation, how the spray dryer work and so on. Okay, so then now we move back to the business that you need to do exercise. Okay, this exercise. I'm going to paste in the chart on the table so that you can have a look on it, and then can copy and paste, right? And then you can plot it. Okay, how I want to upload this. Okay, sekejap, saya cuba upload dekat dalam chat. Okay, chat. So that you boleh, sekarang ni dah boleh dah, kalau you nak copy, if you want to copy it. So now I will put attachment. I think this one. Okay, cuba you tengok. Can you look that exercise? Is the same table ke bukan? Betul table dia. Okay, can you download the exercise one document in the chat?
Yes, doctor.
Is the correct table?
Yes.
Okay, that's good. All right, so okay, now you can just copy it, okay, and then put in your Excel and try to plot it first. Okay, plot it this one, and later on I'm gonna guide you what need to be done after that. Okay, so because our final goal is basically okay, Okay, so this one, so you have like tray size, initial moisture content. So let me explain later on about this. So first plot this graph. Graph. Okay. So what graph that you need to plot? Of course. Okay, it's basically this graph, moisture content versus time. Okay, moisture content versus time. So this is going to be your y. No, moisture content going to be your y. So this is going to be your x. All right. So when you plot it, because this is 116%, so you're going to become in fraction is going to be 1.16. Okay, 1.16. So meaning that you just divide it by 100 lah. You dapat that this is 1.06, this is 0.81, this is 0.618, and so on. All right. So the final goal, okay, they have two final goals here. For this exercise, basically kita akan plot ni, kita panggil free moisture content versus time. So this is time, this is free moisture content. Okay, that is fraction, not in percentage. And after that, we're gonna plot, okay, this one we can transform it into this graph. This is what we call it drying rate curve. It's a rate versus free moisture content. Okay, so then I will explain to you what is the phenomena happen and so on. So first plot this one. Okay, there is two graphs that we should be able to plot it today during this class, and then you'll be able to recognize it. What is that graph? Okay, basically how you can obtain this graph, this data. Okay, this data is basically you're going to conduct experiment. Normally dalam drawing ni, you have to conduct experiment. Then you can get accurate data. So what need to be done? I think if you already took the unit operation lab, I believe that there is one module on the drying, tray dryer. Okay, so the same setup for tray dryer. So normally dalam tray dryer ni, okay, sementara you plot tu, I give you storytelling lah on the experimental run, how they run it and how they collect the data. So this is the tray dryer. Okay, normally kalau lab tu dia ada satu tray je. That tray is basically suspended. Okay, it's suspended tray. So what happen? You're gonna put your material here. Okay, so material here is like one layer je material tu. Must be one layer je. Untuk conduct experiment must be one layer. It's not like multiple layer because it's difficult. But normally you're gonna put like, if you have the tree is like this, you're gonna fill up only until this surface here. Cukup. Sebab you akan ada length here, width here, and you got your height following the tray size. So meaning that the material, the wet material needs to be dispersed uniformly up to the height of the tray. Okay. And this tray dryer is suspended and then is normally connected to a balance. Balance ni you boleh timbang dia punya berat. Okay, weight. Dia punya weight according to time. Okay, as the time increasing, then you can record the time. So this is why you have time here. Alright, so this is why you can record that time. So when you switch on, okay, this tray dryer normally you're gonna have like blower. And then you have heater here, the same like the hair dryer. So the air coming in contact with heater here, and then exposed in contact with the wet material here. All right. So and then it's go out. So go out. Normally we're gonna measure the humidity. We're gonna measure the temperature. We're gonna measure the relative humidity if you have the relative humidity and so on. Yeah, and then from here, how you collect the data? So you're gonna set time, let's say time 0. So what is the wet mass at that particular time? So this is the 116, for example, right? The moisture content. They already calculate. Okay, normally it's not the moisture content because yang ni kita dah skip Sebenarnya data dia adalah daripada start dia adalah daripada time, and then you ada wet weight, okay, yang you measure daripada sini, experimental. So time 0 katalah certain mass. Ni dia tak bagi, dia dah skip. Yang this one dia dah pergi kepada another level, moisture content. Okay, dia dah plot another one because dia already calculate. Okay, but kita boleh pergi lagi kat sini. Di wet weight ni, katalah wet weight dia sini, katalah dia pakai dry solid in use. Okay, for this experiment, let's say dry solid is 2 kilo. Let's say, kita bagi example. This is just example, okay, to demonstrate how to calculate the moisture content. And then, weight solid kat sini, katalah you ada moisture and then you put it 10 kilo, let's say. Initially 10 kilo. So when you run for 1 hour, for example, the wet weight reduced to 8, katalah 8, let's say I put it like 8 kilo. And then 2 hours, let's say they goes to 6 kilo. 3 hours they go to 5 kilo, let's say lah. 4 hours they go to, let's say 4.5 kilo. 5 hours they go to 4 kilo. Let's say, example untuk dapatkan moisture content ni, moisture content is basically equation dia adalah, okay, kat sini kita pergi. Ni, moisture content. XT is W. W adalah dia punya weight, wet weight, masa tersebut, minus dry solid weight divided by dry solid weight. Okay. So kat sini kita apply dia punya equation ni. So kita buat dia exercise ni, and then barulah kita pergi macam mana nak dapat benda tu. Where to get the what is the equation involved. So now, okay, XT untuk yang satu ni T0, W minus WS divided by WS. So W gonna be 10 kilo minus WS is 2 kilo divided by 2 kilo. So you're gonna get what? How much? Eight divided by 2. So this one you're gonna get 4.0. Right? This is 4.0 untuk yang XT here. Alright? So kat sini dia, yang this one, the table here is different because this one I just bagi example dia. Okay, dia punya mass ni. Right, so let's say you cari T1 pula. T1 adalah 1 hour kan? So 8 minus 2 divided by 2. So you kira lah berapa pula dia punya tu, dia punya XT. 8 minus 2 divided by 2. So dia gonna be 3. So kat sini akan jadi 4, 3 and so on lah, you kira. So dia jadi 4.0, 3.0. You nampak, you look that here it's not the same here. Like here, the value here is 116, 106. That no problem because this one is different punya data. So this one is another set of data that I just give example how to calculate this moisture content of XT. So semua dah plot ke? Semua dah plot? Tu tak siap lagi? Pakai Excel je? 3 minit saya siap lah. Can someone show me apa yang dia dah plot? Okay, boleh tak? Volunteer, show your graph. Can you plot? Tadi I explain about how to get the moisture content. You faham tak? You understand how to get it? Okay, kalau ada soalan boleh tanya. Okay, sebab yang data yang I ask you to plot, basically dia dah sampai moisture content. So sebelum dapat moisture content, actual experimental data is basically from wet weight. From wet weight, you use equation xt equal to W wet weight minus WS divided by WS. So you get each of them of moisture content. Okay. So can someone share? Sebab saya tak ada dia punya graph. So I haven't plot it. But I know how to use that graph. Boleh tak seorang? You allowed to share, I think. Tunjukkan you punya graph. Dalam bentuk Excel. Excel je cepat sikit. Tak ada ke? Malu ke nak tunjuk graph? Graph Excel pun malu. Bukannya you plot pakai tangan. Boleh someone? Tak aktif lah you all ni. Tak nak participate. Dia suka saya panggil nama . Okay, Li Fangyi.
Doctor,
Ya.
can I ask for the we have to derive the drying rate, the R1, but I
Yeah.
don't know how to find the LS.
Nanti dulu. So I just want you to plot the moisture content versus time dulu. Graph tu dulu. Show me that graph first.
Okay.
Plot. Kita akan go one by one dalam table tu. Sabar. And I will explain how to get it one by one. So this exercise is basically straight away practical terus buat. So no need to do more. After this you dah habis kelas, tak payah lagi nak ni. Pasal you dah buat dah. Hands on. Okay, you share you punya yang first tadi. Moisture content versus time. Tu je. I want to see that. Which is you just copy paste je then plot graph. Bukannya you calculate lagi. Yang the calculation tadi yang I show you, let's say kalau dia start daripada wet weight. Then wet weight kena guna that formula. Okay. So a nice graph. So you have like time and you have x, right? Okay, so what you have beside the x?
Sorry, doctor, can you repeat?
Okay, because you have 3 columns. One is time, another one is xt. That xt is become x. So you already have value, right?
Yes.
What is that x? So you are advanced.
Oh.
You are advanced. Okay, basically, you thought that you gonna plot this type of graph, the time versus xt. Okay, but you have to remember dalam exercise ni dia ada bagi equilibrium moisture content. What is that equilibrium moisture content basically? How to use that? Alright. Okay. Apa ni Fangi? Okay. You can just unshare because I want to explain. Alright. So thank you very much, Fangi, on your sharing. So after this, you're going to plot basically the improved version. Okay, because you know nothing yet. So when I instruct you to plot just t and x, t, you just plot it, right? But basically, the actual of moisture content, okay, that graph supposed to be okay, because here you have another one. Okay, that's why dekat dalam graph ni, dalam table ni, you have free moisture. Okay, sebab if you remember when I mentioned the first graph gonna be free moisture versus time. Okay, free moisture versus time. Okay, I cannot wait. cannot see this one. All right, now yes. All right. So remember that the graph that we plan to plot is free moisture content versus time. Okay, the one that you plot initially on moisture content versus time. You see that you have the free moisture content. So it's different. It's not the same. So it's okay because we learn from, okay, you plot this one first. Okay, that is not the correct graph. So how to plot the correct one? Okay, this is how I teach you. Okay, now I teach you how. All right. So when you get the moisture content, because the data they give you moisture content, xt, okay, here another equation to get free moisture content. Because you want to plot free moisture content versus time. MC is moisture content lah. Alright, not moisture content versus time. How to get the free moisture content? Okay, the equation is X. So this is free moisture content equal to XT moisture content minus X asterisk. Okay, asterisk basically, what is this? So this is equilibrium moisture content. Okay, so dalam case ni, in this exercise, you see that they have this free moisture is xt minus x star. So which one is x star here? Equilibrium moisture content. So how to get this one? So you have like 1.16. You have to minus with everything with 3.1%. 3.1 meaning that 0.031. And then you get the new value of free moisture. Okay, I think Wang Fang already did it. All right, and did it correctly because you just minus with 0.031. All right, now the one that you're supposed to plot is this one. Free moisture versus time. So you can replot again. Okay, you pakai Excel, senang je. You buat formula equal to 1.16 minus or not 1.16. You ambil apa ni Excel minus 0.031. And then you get one, you just drag, you dapat lah everything, and then you plot. Boleh kan? Okay, do it now. Okay. So of course you want to know what is the equilibrium moisture content. Kenapa ada kena minus dengan equilibrium moisture content? Okay, remember, please remember that some condition, the equilibrium moisture content can be zero, meaning that the xt minus zero, you get x equal to xt. Okay, kalau dia tak bagi value, you can assume dia sebagai zero. If they did not provide any equilibrium moisture content value, then you can assume as zero. Kena ingat tu. Tapi even they not providing the equilibrium moisture content, kalau dia tak provide, you still can get that equilibrium moisture content dekat dalam you punya buku. Kalau ada dalam buku you, dalam buku textbook, then you should use that value dalam buku. Maknanya, it doesn't mean that if the equilibrium moisture content is not given for that particular wet material, it doesn't mean that it's supposed to be always zero. Okay, you kena tengok dulu dalam buku you. Okay, dalam buku you nak tengok yang mana? Okay, macam mana nak dapat equilibrium moisture content? Okay, very simple. Okay, I teach you. Okay, now I explain. Now I go back, okay, to the slide. What is equilibrium moisture content? So the learning process today is, of course, I say different because we come across with that value and then we go back to explain what is that. So I think that it's going to be like more effective compared to I introduce and then you're going to meet this value maybe next week. So you will forget. Okay, so equilibrium moisture content is basically moisture content that attain when the wet solid is exposing to large excess air. Blah blah blah. Okay, you cakap apa benda ni tak faham. Okay, apa benda dia cakap pun tak tahu. Okay, equilibrium is basically, okay, it's very simple. Equilibrium, anything akan reach equilibrium at certain condition. Okay, equilibrium maknanya tak ada yang keluar, tak ada yang masuk. Kalau equilibrium with the correct, okay, let's say this is your wet material. So with the correct temperature, humidity, alright. So you're gonna reach Okay, the drying process gonna reach end point at equilibrium. Equilibrium meaning that you punya water ni takkan jadi vapor lagi. Will not become vapor. So what happen? Your water akan retain dalam wet solid ni. So maknanya you tak boleh buat, you takkan dapat, you will not achieve complete 100% water removal. Okay? You tak boleh achieve. You tak boleh achieve this. Because of what? Because when they reach equilibrium with certain temperature, humidity and relative humidity, okay, dia akan depend pada relative humidity. So more water no longer will escape as vapor. No longer. Dia akan still retain dalam solid. So maknanya solid you still akan ada moisture. So that's why kalau if you notice that bila you buat drying pun, you akan still rasa little bit of wet certain material. Because of what? Because they already reach their equilibrium, dia condition. So maknanya water tu still lagi retain dalam material, but it's very low, relatively low punya content. But they cannot more they cannot remove more because they already reach equilibrium at the condition that you put it. Okay, like say you letak kat luar dekat you drykan you punya wet clothes. So you ambil dia rasa macam lembab-lembab, especially masa wet condition ataupun rainy day. You rasa macam kering tapi you akan rasa macam lembab-lembab sikit. Basically there's some moisture there. Because of what? Because condition pada masa tu dia akan reach equilibrium at a little bit higher water dalam you punya clothes. Okay, so how to get the value? Okay, equilibrium moisture content. This one you boleh dapat daripada textbook you. You refer pada figure 941 and then figure 942. So 941 for example, this is for certain I would say that is non-biological material lah, non-food. Ada paper, ada wool, ada nitrocellulose and so on. So kalau kata dalam soalan, if let's say in the question, they mention about this type of material and then they're not giving you the equilibrium moisture content value, so don't assume that it's a zero. Okay, basically you can get it from this figure because that is the purpose of open book. Alright, open book question. Everything is there. Okay, everything is there. So suppose that do not text me saying that, sir, there's no equilibrium moisture content value is given. So how? I will not answer that. I will just keep silent. Because if the material they mentioned is listed here, you can get it from the table. Okay, no need to provide the value as additional. Okay, so if you look here, okay, this one, another one here, 94 is for biological food material lah, some of food material. For example here, macaroni lah, ada flour, ada bread, ada crackers, puasa ni kan, macaroni, sedap ni. Alright, so this is the punya data lah. This is basically theoretical data. Okay, some people conduct experiment and then they get this as a theoretical data, fundamental data. Okay, how to use this one? Okay, this one you need to know your relative humidity. That's why masa conduct experiment tray dryer, you kena okay, that's why you kena tahu relative humidity of that tray dryer experiment. Tray dryer ni kan you ada tray dryer, you dah letak you punya material, you punya air tu going out, and then you kena measure dia punya relative humidity. Pasal apa? Because you want to know your equilibrium moisture content. Let's say like if your sample is I would say sample number 2 lah. Let's say sample number 2. Number 2 is wool. So you put wet wool in your tray dryer experiment and then you measure relative humidity, and that relative humidity, let's say they bagi you 20% of relative humidity. So macam mana nak baca? Okay, you tengok sini 20%, you pergi ke atas ni. So this is the equilibrium moisture content of that 20% relative humidity of wool. Macam mana you want to get the X star ni? Macam exercise tu they give you because they did not mention any material type. Kalau they mention, then you boleh pakai figure this one and another figure. 941 and 942. Alright. Macam mana saya beritahu how I told you before that X equilibrium can be zero, can reach zero. Bila? Okay, you tengok figure ni, when relative humidity is zero. Okay, when 0% relative humidity, then you get zero here. Then you punya X akan jadi zero lah, X equilibrium. Okay, so maknanya kat sini, if you want to completely remove your moisture, okay, you nak remove moisture kan, semua kan. So apa yang you kena buat, you make sure that your drying condition, you punya relative humidity must always at 0%. Itu je. Sebab at equilibrium, there's no moisture content at all. There's nothing moisture content. Maknanya, you boleh remove lah semua sekali. But if your relative humidity is certain percentage, you're gonna expect that some moisture still remain there because you know that this equilibrium moisture content, the unit is kilo of water over 100 kilo of dry solid. Maknanya, kalau katalah kita ada 8 kat sini, so maknanya you ada 8 kilo of water dalam 100 kilo of dry wool. Dalam kes nombor 2 lah. So you just imagine dalam 100 kilo of dry wool, you still have 8 kilo of water. You tak remove pun 100%. Pasal you punya relative humidity is 20% that time, katalah. But if you want to remove everything here, 8 kilo ni, you punya relative humidity must be at 0%. Then you akan dapat 0 kilo H2O over 100 kilo of dry wool. Okay, I hope you understand how to use this, how to get the equilibrium moisture content, and how to use this figure 942 and 941. Boleh? Boleh, simple je kan? Okay, kita tengok satu lagi example. Let's say you run drying, your relative humidity, your material here is basically macaroni. Let's say macaroni. Macaroni. And relative humidity katalah 100%. Okay, you tengok macaroni. Macaroni nombor 1. Okay. Lepas tu cakap 100%. Alamak. Okay, you see that? Oh, 100%. Tak ada graph. So how? What to do? So what is the equilibrium? Takkan you cakap kosong. Ataupun you ambil 80%. At 80%. Tak. Okay. Kalau yang tak ada kat sini, you kena extend on your own lah. You extend sendiri. Ni 100%. This is 100%. So you baca lah sendiri kat sini berapa. It's about what? Maybe 25. So it's going to be 25 kilo H2O over 100 kilo dry macaroni. Okay, so this is also equivalent to 0.25 lah. Kilo H2O over 1 kilo of dry macaroni kalau you bagi dengan 100. Okay, ini kalau case yang tak ada tepi ni. Kalau yang ada, you ambil lah. Let's say relative humidity dia 60. So 60 pergilah sini. So you get, this is the value of X. Start, okay? Boleh? I think that is very simple kan? Right, so now you dah calculate sini. So you dah boleh calculate sini, then you boleh buat graph lah. I hope that you already pick your graph. Dah kan? Dah dapat. Okay, dah dapat graph tu, very good. Okay, saya tak nak you share, tak apa. Saya akan move on to this one. Drying rate pula. Okay, moisture content ni, dah tahu tadi kenapa, apa dia, what is that moisture content and how to get it, equilibrium moisture content, and why you need that, because you want to find your free moisture content value. Because we don't want moisture content. So how to get the moisture content? Moisture content is basically the wet weight minus WS divided by WS. Okay, kena ingat balik tu. Okay, yang ni dia bagi initial, this is final, kat sini lah. Ini adalah sama je data dia yang ni. Okay, this is tray size. So nanti kita akan tengok apa kegunaan dia. Alright, so now you dah complete dah plot dia ni. So you dah pass lah. Okay, very good, very nice. Okay, say apa ni, congratulations to yourself. You are doing good. You be able to plot free moisture content versus time. Okay, which is very good. Kalau saya tak buat ni, you belum tentu lagi akan buat. Okay, and then maybe you tak understand pun how to get that value. Alright, now kita nak move ke another one. Okay, this one. Rate versus free moisture content. Free moisture content dah ada tak? Dah ada. Gunakan yang tadi X tadi. Now, nak dapatkan rate. How to get that rate? Okay, how to get that rate? Ni dia tak tricky pun, tapi let me introduce satu. Rate of drawing is basically adalah LS over A dx over dt. Kita tengok balik equation kat sini. Okay, ni. This is to obtain rate of drawing. Okay, rate of drawing yang macam ni, kita ada R, kita ada T, kita ada X. Kita nak plot benda ni. Okay, you want to plot this one. So you need to get data of R. So what is R? R is drawing rate. So drawing rate equation dia adalah minus LS over A dx over dt. Okay, minus LS over A dx over dt. So mana nak dapat this thing? Okay, LS adalah sama dengan this one. WS. WS adalah weight of dry solid. Okay, so LS adalah dry solid weight juga, sama. Cuma apa beza dia? Kenapa dia pakai one equation dia pakai, they use W, another one they use LS. Okay, untuk eksperimen, normally you akan pakai W. Okay, that is different. Untuk theoretical equation, so they use L sebagai LS. The value is the same. Okay, so LS over A adalah area. Okay, area mana? Okay, kat sini kan ada tadi dia bagi. Okay, sorry, this one. Macam dia dapat area, dia dah bagi tray size. So basically, bila you run experiment, the material supposed to be cover all the tray. So maknanya size dia adalah sama dekat tray lah. Okay, so dia tak boleh sikit daripada tray, 30% ke tak boleh, dia kena sama. Barulah efektif dia punya data tu. Kalau tak, data dia tak akan dapat yang cun. Okay, yang the best punya plot lah. So you dapatkan area mana? Area kali apa? Length kali dengan width lah, jangan kali height. Height you dapat volume. Okay, kita nak area je. We want only area Jangan pandai-pandai nak cari volume. Ada yang terlebih sikit cari volume. Okay, area dah tahu. LS tak tahu. Okay, LS. Saya kena bagilah LS. Sebab dalam ni dia tak bagi kan. They're not giving you any LS. So, what value LS you can use? Value mana nak pakai? Pakailah macam dalam buku. Textbook LS berapa? 46 point something ke 20 something. Saya lupa. Dalam buku yang ada graph tu, LS berapa? The mass of dry solid. Boleh, can someone help me? But you need that value. Berapa nilai dia? LS? Sebab saya tak ada textbook. So you all pun tak pakai textbook? Hello. Boleh bagi nilai? Can someone? Ada tak nilai LS? You tengok balik dekat dalam textbook tu, experimental determination rate of drawing curve. So dalam tu dia ada bagi I think dia bagi dry solid weight berapa. Kalau dalam ni dia tak ada bagi. Dia tak ada. They're not providing any value here dalam slide ni. Tak ada yang boleh bantu saya? Ke semua tengah sibuk nak kira free motion dengan plot graph? Tak apalah kalau tak nak bantu saya, it's okay. You just use the LS value dalam buku teks. Textbook. Saya tak tahu value, kalau saya tahu saya letak. Okay, tak ada orang boleh bantu saya, it's okay. Saya kelas dengan batu rupanya. Okay. And then dx over dt, where to get the dx over dt? Okay, remember that you punya plot tadi apa? You punya plot adalah, okay, kalau you tengok sini adalah x versus t. Okay, free moisture x versus t. So dx over dt mana nak dapat? Dx over dt basically slope. Okay, the slope here, the slope. So this is adalah dx over dt. So macam mana nak buat? How to do that? Okay. Tadi you dah dapat plot x versus t. Plot dia macam gini, lebih kurang. Okay, more or less. So now you kena identify, you kena select beberapa point. Let's say you point, this is point A, this is point B, this is point C, this is point D, this is point E, F. Contoh, example. So what you need to do, cari tangent dia. Okay, this tangent is basically dx over dt untuk A. So this is another tangent, dx over dt. So this is another tangent, dx over dt. So this is another one. So this is another one. So this is another one. So apa you buat? Dekat you punya table ni dia akan jadi, you boleh kira dia punya R is equal to minus ls over A dx over dt tadi. Yang point-point you pilih. So maknanya akan ada point yang tak ada, akan kosong. So akan ada kat sini contohnya, sebab dia depends pada point yang you select dekat graph ni. Dia akan depends. So sini berapa time dia, sini berapa time dia. So you akan completekan table ni. You will complete the table based on time yang you select tadi. Okay, you akan ada R kat situ untuk yang certain time lah. Not every single time ni akan ada. Tapi kalau you boleh buat every single ni, perfect. Cantik. Okay, kalau you ada every single time, you can plot dx, you can get the R value by finding the dx over dt of each of them, then it's perfect. Okay. Kalau you tak, sebab puasa kan, so you akan shortcut lah. Kalau boleh you nak satu point je, tapi you cannot plot one point. It must be a lot of points. Okay, so this is example lah. Let's say this is kat 36 ke, yang ni dekat 100, I don't know, 194 ke, I don't know. You select the point, not me. Alright, so that's why the answer will be not the same between you and another. So graph punya, the good thing about graph punya question, kalau you tiru kawan you tak boleh tiru pun, because cara you draw graph will make different bila you plot you punya slope. Okay, slope you kalau sama dengan kawan you tiru, bila kita tengok balik slope you dekat graph, tak sama lah, kosong markah, you tiru. We know that. Okay, very simple. So you do it, then you get your answer, you punya value. You takkan sama dengan kawan you, because the way that you draw this, contohnya you ada sini, untuk you draw you punya tangent pun lain. Okay, between you and your friend. Your friend mungkin dia akan plot sini sengit sikit, tangent dia, you akan begini sikit. So akan different dia cara you draw you punya guna pembaris tu lah. Okay, once you get everything here, let's say this is dx dt untuk A, dx dt untuk B, ni dx untuk C and so on. So you insert lah dalam table ni. Okay, table ni pun boleh juga kalau nak extend satu lagi. Kalau katalah make things different, confused, you boleh je buat kat sini dx over dt dulu. Lepas tu barulah you plot R, rate of drying, ls over A, dx over dt pun boleh kalau you nak, takutlah step to miss kan. Lepas tu dah kira ni semua, barulah you plot R versus X. Okay, you boleh try. Yang ni you boleh try. I think this is take time. Okay, yang ni takes time because you nak dapat ni. dx over dt ni ambil masa sikit. Kalau dekat Excel tu, I don't know macam mana you nak buat. Tapi you boleh cubalah. Kalau you boleh print and then you buat manually, then you akan dapat. So please complete this one lah. Okay, LS value nak dapat mana? Pakai dalam buku teks, textbook. Alright. Saya tak tahu value dia berapa pasal tak ada orang tolong saya beritahu berapa nilai dia.
Doktor,
Ya.
21.5 ke?
Ya, terima kasih. Sebab itulah saya nak someone help me. Kalau tak nanti cakap, pakai nilai mana? Nilai mana? Saya dah cakap textbook. Textbook yang mana? 21.5 kilo. Okay, pakai ni sebagai LS. Okay? Untuk completekan yang ni. Okay, then you dapat ni. Nanti you akan boleh plot R versus X. So you akan dapat you punya point A, point B kat sini ke, C, D, and then you akan plot benda tu. You akan dapat pattern dia nampak lebih kurang macam ni lah. Tak adalah perfect, tapi you akan dapat almost. Okay, you akan dapat almost like this. Okay, from this graph, so now you know how to get this graph, rate of drying. Okay, it's from experiment. Experiment you plot. You dapat W. From W you get the moisture content. From moisture content you get free moisture content. And then you can plot free moisture content versus X. From free moisture content versus X, you can get rate of drying, dx over dt of individual point. From there you can get this, what we call it, drying rate curve. Okay, this is drying rate curve. Okay, so nampak kan? Ada soalan tak? Sebelum I explaining about this rate, drying rate curve. Dan tadi tu you boleh try lah you. Sebab itu ambil masa sikit. Okay, to get the R, it takes time because you need to get the tangent for each point that you select. Okay, so jangan buat mistake. Do not do mistake. Sebab ada sebelum ni, when we did this exercise, masa tu face to face, that time is face to face, I think it's back 2019 ke 2018. So what happened is that student, dia tak nak draw dia punya tangent tu, dia tak nak draw tangent ni, so dia buat apa? Yang ni tolak ni, bahagi dengan ni tolak ni. Salah. That is wrong. This is wrong. Dia ambil data ni tolak ni, ni data ni tolak ni, dapatlah point kat sini. Salah. Okay, that is not correct. It's basically you need to get the tangent from that. Kalau just imagine kalau you do like that, you akan ambil point sini, tolak point sini. So basically, it's not tangent. It's along that line, on the line. Basically, we want tangent dx over dt. Alright? Banyak yang buat mistake tu. Okay, now, okay, nanti you plot and then you boleh tengok balik next week boleh share dengan saya graf you dapat macam mana. Dia mungkin tak perfect macam ni, dia mungkin akan dapat macam little bit je yang dekat constant tu and then baru macam tu, mungkin dia akan dapat macam tu, tak silap saya lah. So dah lama saya tinggalkan this exercise. Alright, then you see that you tak rasa pun the time to 2 hours is a very long time kan. Pasal bila kita buat exercise ni sekejap je dah 11:22 dah. Okay, very very short time. Okay, that's why bila kita buat exercise and then katalah you ada soalan dalam kelas kita tanya ask so many question. 2 hours class is basically is very short. Okay, you tak notice pun sebenarnya. Dah habis dah waktu kelas. Tapi kalau you just keep silent, tanya soalan tak jawab, ada soalan tak ada, memang you akan rasa lama je kelas ni berlalu. Trust me. Okay, so you akan observe akan ada this is where you get you see that this line, this is rate of drying. Okay, since you see that this one is flat, flat. So that's why they call it constant rate. Kalau you ada, katalah rate sini nombor dia berapa. Ini jangan pakai nilai yang ni. Nilai ni lain berbanding dengan exercise you. It's different. It's not the same. This is yang daripada textbook. This is to show you the pattern. Okay, the graph behavior gonna be like this. Okay. So here, let's say dia punya value adalah 1.5 lah. So any point here in between B and C, the rate of drying is 1.5. Antara free moisture ni 0.4 pun 1.5, 0.3 pun 1.5, 0.2 pun almost 1.5. Alright, so that's why dia panggil sini constant rate. Okay, constant rate period. Because the rate of drying is constant, dia punya value. Okay, another phase yang you kena tahu adalah dalam drying, we have falling rate period. Falling rate ni, why they call it falling? Because kalau dekat sini, rate of drying dia lain. Sini let's say this is 1.1. You put another moisture content here, this is going to be like 1.0. The rate of drying dah decreasing. So that's why they call it falling rate. Okay, so to conclude, in the drying, you're gonna observe a very distinctive period. One is constant rate period, we call it constant rate period. Another one is we call it falling rate period. Boleh? Finally kita sampai kat sini lah, constant rate dengan falling rate. So equation nanti kita akan tengok, this is experiment bila kita pergi equation nanti, katalah you don't have time to run experiment. So you tak ada data boleh plot macam ni. Tapi still you can calculate rate of drying and drying time. Dengan menggunakan equation whereby that equation will be taking into account the heat transfer and mass transfer. So even that equation, bila you dekat constant rate, when you are in the constant rate period, you gonna use equation constant rate. Dia ada equation dia. Dekat falling rate, dia ada equation untuk falling rate. So meaning that dia tak sama. It's not the same. You need to know one point here. Okay. What we call it, that point is, I need to delete first. Here, this point, okay, the turning point from constant to become falling. So this one we call it here, XC, critical free moisture content. XC. You kena determine where is the XC point. The critical free moisture content. The critical free moisture content. You need to determine because that is the turning point whereby equation, you need to change equation. Okay, equation falling. This one you nak calculate, you pakai equation dekat constant. Let's say I give you a simple example. You ada wet material, wet solid. You want to dry it initial at 0.4, katalah initial moisture content adalah 0.4, and then you want to dry it until X final kepada 0.1. Okay, you see that you have, kalau you referring to this graph, 0.4 until 0.1. Kalau you tengok kat sini, if you look into this graph, if you want to dry for this from 0.4 to 0.1, dia akan come across dekat XC kat sini. So maknanya you kena separatekan that phase. Okay, this is constant. You use equation constant kalau pakai equation lah. Kalau falling, pakai use equation untuk falling. So different. Alright. So maknanya kalau nak dapat contoh lah, let's say you want to find the time for drying. So you kena campurkan dua, time dekat constant, campur time dengan falling. So time dekat constant, dia ada equation ni lah. Dia ada equation. Basically time dekat constant tu adalah dari 0.4 until 0. Let's say this is 0.2 lah, XC. 0.2. TC. Campur from 0.2 until 0.1 untuk TF. So dia equation ni lain, equation ni pun lain. Okay, faham? Kenapa pentingnya you need to determine where is your XC? Okay, dalam case contoh lah, in the case that let's say you punya drying, you want to dry from 0.5 until final 0.3, let's say. So you know that 0.5 is here, 0.3 here. Biasanya katalah A dengan B ni tak ada, dia extend sikit kat sini. Okay, 0.5 ni akan ada kat sini. So dalam graph yang you buat tu, nanti exercise you takkan ada point A ni, A prime dengan A. You takkan ada, dia macam flat je. Okay, kalau dia flat, let's say you punya moisture content tu tak sampai dekat point tu, you boleh extend dia. You boleh extrapolate. So this is 0.5 until 0.3. 0.3 kat sini. So you nampak kan? You see that they are in the same region, in the same period, constant. Jadi you boleh menggunakan, you can use only one equation and then you can get the total time lah tanpa you add on dekat yang falling. Pasal dia punya drying pun hanya dekat constant sahaja. Boleh? Can? Understand? Understood? Someone respond me? It's okay or not? Are you still okay? You are there?
Yes.
Yes, of course are you still there, right? Okay, so then once you know that, okay, dari constant rate, now I explaining based on this rate of rate of drying curve, actually what happened during drying? Apa yang berlaku? Okay, apa yang berlaku? I will tell you a nice story. So this is kind of tale story lah. Okay, it's not really a tale, but it's basically the actual phenomena what happened in the drying. All right. Okay. Let's say this is your wet material, wet solid. So you have like moisture inside it. Okay, and then you expose to dry air. Dry air, hot air. Okay, you boleh pakai je normal air. Tapi lambat lah drying. Okay, normally dia akan little bit higher temperature. So you'll know the temperature, you will know the humidity, alright? Maybe you will know the fraction of moisture that carry together with the air, dry air that you supply. So, and then it's in contact with the area. So that's why it's very important to have area, because the one that is going to be most contact to the dry air in drying is basically the surface area here. Okay, the surface area. So let's say if I can take a look here, I zoom in, okay, this section. So I'm going to get something like this. Okay, this is your solid layer. All right, solid layer. And then this is the air that coming. Right? This is normally the Y1 lah. T1, H1 yang supply. T1, H1, Y1. Okay, dalam ni ada, mana dia keluar? Dia keluar ni mungkin T2, H2, on. And here you have moisture. Okay, I draw a different color. Let's say moisture dalam ni banyak water, alright? Inside. And on the surface here, you also ada water layer. Dia wet kan? Okay. With water layer. Water film. Very thin film Actually, macam mana, how you can imagine that you have that? It's very easy. For example, you ada sponge, you try ambil sponge, you immerse dalam water and then you take it out. You're going to feel that this is a very small, very thin layer of water film on the top surface of that wet sponge. Okay, sponge tu dia dah absorb lah water, right? So on the top surface, you akan feel ada water layer punya film. So it's like that. Okay, wet solid view. Depending juga dia punya amount of water lah. Kalau banyak lah, right? So when they expose to this hot air, so dengan supply heat kat sini, heat akan bagi kepada wet solid. So this heat akan giving into the system, giving into the solid, the wet solid. So what happen? Heat tu akan transfer to water. So water ni nanti akan keluar lah. H2O akan keluar sebagai, bila dia cukup energy, they will release. Okay, they will release as a water vapor. Right? So what happens is that, as you supply the hot air, so all the water that will be removed is basically on the surface side dulu. Okay, H2O yang daripada surface ni saja yang akan remove. Yang ni akan naik atas. Yang dalam ni, what happen to the inside? Inside there is no interrupted at all. They will not interrupted at all. So there is no moving. So they will remain there, static. Okay, static there, because that's why in drying it happen on the surface of drying, the surface of material. So that's why it's a surface. So dia akan, yang surface ni akan naik atas. So bila dia dah naik semua, katalah dia dah naik semua ni, so what happen? What left? Dah tak ada water film. Okay, dah tak ada water film. So masa yang dia naik semua tu, okay, masa yang water film yang they are going up, so what happen is that the rate of drying here, rate of drying is basically equal to rate of what? Evaporation. Okay, evaporation, because it's all totally depending on the surface yang going up, and the rate here is constant. It's not changing, it's the same. Alright, it's the same. So that's why here you get this constant rate, because it's only the surface that the one that removing, the first one that will be removing the water moisture there, that one that you're going to remove. So the rate of drying is equal to rate of evaporation, and the R is constant. So that's why you get constant rate kat sini. Boleh faham? Understand? Can you understand? Ada soalan? You need to understand it really, because really understand it, because this is a theoretical behind it. Because remember that the cost outcome, you need to be able to explain what the mechanism involved, what is the fundamental. So this is kind of question that may be going to be asked in the quiz. So explain the explanation, the mechanism, what actually happened during the constant rate period, what happened in the falling rate, for example. Right? So if you do not understand, please ask to clarify things. Okay, do not pretend that you understand kalau betul-betul tak faham. Okay, so now yang ni dah remove the thin layer dah remove. So what happened? Yang next is basically water yang dekat dalam, inside this solid. So what happened? The one that nearest to the surface, the one that gonna go up. Okay, yang ni akan go up, go here. Okay, dia akan go up, dia akan moving out. Okay, when they moving out, what happen? Dia akan gantilah, they will replace the one that dalam atas surface ni. Dia naik ke atas ni. Okay, dia naik ke atas ni, and then once dia naik, dia akan naik evaporating. Okay, because you are keeping supplying the hot air, so dia akan whip away with the hot air that supply as a water vapor. Dia akan naik. So what happened? So bila dia naik tu, this one dah tak ada. Okay, this area, this depth dah tak ada water. Okay, so kalau kata, okay, let's say if your drying time is not enough, trust me, you boleh take it out from your oven ke, you're gonna feel that, okay, you're gonna feel that the bottom still wet, but the top surface is dry already. It's already dry. Okay, tak percaya you buat. Okay, you akan rasa dekat atas ni, ini dry area already. But bawah ni masih lagi macam wet. Because of what? Because it's moving up to the surface. Okay? Okay, unless you have like, you exposed to all the side. You expose air kat side sini, kat sini, kiri kanan semua. Then mungkin dekat tengah lah yang akan jadi wet. Ni especially dekat raya ni kan. You have your mom, because you semua dekat rumah kan. Work from home, online. So then you kat rumah, you tolong your mom buat cake. Let's say you buat apa ni, chocolate cake. You buat bulat. Okay, dia memang expose semua sekali, but you will notice if the drying time is not enough, apa berlaku dekat tengah ni masih lagi cair. Dia tak dry. Sebab dia semua side dia ada, tapi dia akan moving towards the inner core. Inner core tu yang akan lambat panas. Okay. So next, yang lain-lain akan naik jugalah. Okay, dia akan moving. Bila dah tak ada sini, dia akan moving. So the movement here, okay, if you see that the distance here is one thing lah. If you have longer distance, so the rate of drying will be much more slower. So dia akan turun. As you punya water kat sini, dia akan naik atas, lagi jauh dia nak lalu. So the rate of drying become much more slower. So that's why dia akan ada yang falling ni. Okay, because the distance is now already further from the surface. So the rate of drying becomes slower and slower. Okay, and then the mechanism involved here in the falling rate, how the water moving out, currently they have two mechanisms. Okay, two mechanisms. They're associated with the movement of water to the surface. One is basically through diffusion mechanism. Another one is through capillary flow mechanism. So macam mana nak tahu diffusion atau capillary flow? Okay, diffusion ni dia depends pada material type. Let's say the material type is like paste ataupun sauce, kan? So dia paste. So bila dia paste, the mechanism associated with it is basically diffusion. So dia akan diffuse lah, because you have concentration different. Concentration sini higher, concentration sini rendah, or moisture. So higher pergi ke rendah. So that's why dia ada driving force untuk dia naik ke atas. Cakap macam mana boleh naik? That is basically mass transfer. So go back to your mass transfer, buat revision. Okay, pasal later on, when you come across with the equation, dia akan ada input of mass transfer dengan heat transfer. And if the material is like, they have porosity. Ni macam adsorbent kan? Adsorbent ada poros kan? Porosity, so they're gonna use the capillary flow mechanism. Porosity ni macam mana? So this is a phase, so dia akan ada pore itu. So what happen? Water ni akan masuk sini, akan naik atas. Water ni akan masuk sini, naik atas. So the capillary flow mechanism. There are the two mechanism involved in the falling rate. Okay? So here, in this slide, they are explaining everything here. Okay, what I already explained. Okay, I explained it graphically, but here they are putting in the words. Okay, maybe ada yang tanya kenapa ada A prime dengan A ni. Okay, basically the A and A prime is basically your initial temperature of your wet solid before they entering the dryer. Okay, let's say you punya wet solid tu you preheat. So dia punya A ni akan ke atas lah. It's hotter than the dryer punya setting. Let's say you setting dryer 60 degrees Celsius. But this one solid, you preheat to 70. So dia akan jadi ke atas lah. Okay, dekat sini adalah cold wet solid. So let's say you tak panaskan pun, it's 30 degrees Celsius. So dia akan jadi point kat bawah ni. But point antara point A to B, kita akan ignore. We will ignore it because that is considered as non-equilibrium point. Dia baru nak reach equilibrium, meaning that the heat start to transfer to the wet solid and the temperature profile is not steady yet. So that's why we call it non-steady state. So we will ignore it, we will not calculate it because that is maybe about a few minutes or a few seconds depending on the solid punya size lah. Okay, boleh? Question, I would like to hear question.
Doctor?
Yes.
Doctor, can you hear me?
Yes, clearly.
Okay, so Doctor, I want to ask regarding about the graph for R versus X.
Okay.
So just now when I tried to find the gradient for each point, and then I realized that the graph for free moisture versus time was negatively sloped, meaning that for each point, the gradient I find will be negative. So the graph for R versus X would be inverted lah, as what Dr. shared just now. Meaning dia akan terbalik lah, dia akan ke bawah.
You tak dapat macam ni?
Ni dapat sebiji, tapi because of this graph, the gradient will be negative because it's slightly.
Yeah. Because you know the equation of R is equal to minus LS over A. You're negative there. Don't worry.
Okay. Oh yeah. Missed out.
Yeah,
Okay.
you missed that. You missed this minus. Okay, that's why they put minus.
Okay, thank you, Doctor.
Right, thank you. It's okay. It's a good question. Basically, maybe some of you are missing this minus. Then you ingat terbalik tak sama macam ni. It's basically that's why they ada minus, because the slope going to be negative, so you have like negative sign in there, then you get positive. Okay, question lain? Ada? Okay, tak ada. Biasanya you all tak ada ni. You all nak berbuka tadi rasanya. Ke nak pergi bazar Ramadan? Tak prepare lagi semain Jumaat kot. Yang lelaki ni kan, tak ada soalan. Tak sabar-sabar nak bentang sejadah. Okay, so then once we know that, okay, all this graph, how to plot it, and then what is the situation, what is the phase that involved, then you are good because you already know the fundamental, you already know what is mechanism involved, and then you know that you have two kind of phases, constant rate and falling rate, and later on we're going to go to how to calculate each of them. Okay, for example, the time for drying, okay, the rate of drying, for example, if you don't have the information of R, so how to calculate it. Okay, so then after this, it's going to be much more easier because you already like 50% know about the drying mechanism and process. All right. So I think it's already 11:46. So I just want to stop it here because I know that you're having so much fun plotting the graph, because so far until week 4, maybe you are not really get used to do exercise during class, but today I try to impose this one to expose to you. At least when the class finish, you don't have to plot it again. Of course, you have to plot it because the R is, the R is a little bit tricky. It takes time to plot it. And also it's gonna be like a kind of exercise for you later on if the question of drawing come up like this graph, so it's easy for you and very fast for you to do the plot, because you cannot use Excel, okay, because this is exercise during class. Of course, I allow you to use Excel, but the dr over dx over dt, you still need to find it manually, So then if you can print it and then find it manually, and then you can plot another graph. All right, I think that's all for today. So thank you very much on your attendance. So hope to see you next week, all right, on the more interesting, not challenging, but more interesting calculation in the drawing. During that time, I'm going to explain to you the slide that before coming to the experimental plot of rate of drying. Okay, because you have like a few slides over there explaining about certain parameters. So that parameter, basically you're going to use it in the calculation. Okay, in the plotting, you need to use just a few equation like moisture content, free moisture content. But for calculation, involve heat transfer and mass transfer. Then you're going to use that parameters in terms of humidity, in terms of volume, okay, humid volume, humid heat, and so on. So please do study first on that, because you're going to use it next week. All right. So thank you very much. So Assalamualaikum. See you next week. Happy weekend, everyone.
Thank you, Doctor.
Thank you, Doctor.